All right, so today we are going really, really small.
Like really small.
Yeah, like smaller than small.
Like you might need a microscope to see it small.
Exactly. We're diving into the world of nanotechnology.
The science of the super small, where we can practically rearrange the atoms of a grain of sand like it's a Lego set.
Which, as someone who spent a suspicious amount of time playing with Legos as a kid,
Who didn't?
fair point. But seriously, this stuff is mind-blowing. We actually took a deep dive into an Alternative World podcast episode that explored nanotech.
And let me tell you, they really got into both the incredible potential and the, well, let's just call them challenges of nanotechnology.
Yeah, challenges is one word for it.
Yeah.
But before we go there, let's start with the basics. What exactly are we talking about when we say nano?
Okay, so picture this. Something so small that a human hair looks like a skyscraper in comparison.
Okay, I'm picturing it.
We're talking about manipulating matter at the scale of nanometers.
Nanometers. Remind me again how small we're talking.
A nanometer is 1/1000th of a meter. 1/1000th? Okay, yeah, that's pretty freaking small.
It's hard to even wrap your head around, right?
It's like trying to picture an ant carrying a watermelon.
Pretty much. And here's the kicker. Things start behaving really differently at that size. Like, totally different rules apply. It's like discovering a whole new dimension of science.
So we're basically talking about a whole new set of rules for how things work.
Exactly. And with those new rules, we have a chance to rewrite the possibilities in fields like medicine.
Okay, medicine, always a good place to start. What kind of medical breakthroughs are we talking about here?
Well, the Alternative World episode really blew my mind when they talked about using nanotechnology to create targeted drug delivery systems.
Targeted drug delivery. So like instead of just flooding your whole body with chemo, we could send microscopic submarines loaded with medicine directly to those cancer cells.
It's like microscopic smart bombs, but for good. We're talking about potentially eradicating tumors with pinpoint accuracy, minimizing side effects, and completely revolutionizing how we treat diseases. It's incredible. It's like something out of Star Trek, but in real life.
Right. And it's not just medicine. The energy sector could be completely transformed by nanotech.
Okay, tell me more about that.
Well, they were talking about things like solar panels, so efficient they could make our current ones look like clunky calculators from the 80s.
No offense to the 80s.
None taken. But seriously, imagine a world where energy is abundant and sustainable. Nanotechnology could hold the key to unlocking that future, more efficient solar panels, batteries that last for decades. We could be on the verge of solving some of our biggest energy challenges.
It sounds almost too good to be true, and it makes you wonder, what's the catch?
There's always a catch, right?
Sadly, yes. But let's not get ahead of ourselves. Before we dive into the potential downsides of all this nano-awesomeness, we should probably talk about computing power.
Oh, right. I almost forgot. Nanotechnology could also lead to processors so small and powerful they make our current smartphones look like, well, just phones.
No more doom scrolling for us. Okay, I'm kidding. But seriously, how small are we talking?
Imagine shrinking a computer chip down to the size of a virus.
A virus. Okay, yeah, that's really small.
That's the kind of leap in processing power we're talking about. It could unlock new possibilities for artificial intelligence, quantum computing, things we haven't even dreamed of yet.
I feel like we need to hit the pause button for a second because my brain is starting to short circuit a little bit.
It's a lot to take in, that's for sure.
It is. It's exciting. But also, like, what could possibly go wrong?
It's important to remember that with any new technology, especially one this powerful, there are always risks.
And when we're talking about manipulating matter at the atomic level, those risks could be pretty huge, right?
It could be. And the Alternative World episode didn't shy away from those potential perils. Honestly, some of them kept me up at night.
Yeah, me too. I'm kind of glad I wasn't the only one who felt that way.
It's not about being afraid of the future.
More like being cautiously optimistic.
Exactly. It's about understanding the risks so we can mitigate them. And there's some big questions we need to ask ourselves before we go full steam ahead with nanotechnology.
So what are some of the things that keep those alternative world folks, and let's be real, all of us up at night? Let's dive into those risks. Okay, so risks. Hit me with it. What are we talking about here?
Well, picture this. You're trying to clean up a spilled cup of coffee, but instead of a sponge, you only have a handful of dust.
Okay, that sounds messy.
It's a good analogy for what we're dealing with when it comes to environmental contamination with nanotechnology.
Because these particles are so small.
Exactly. They're so small they can slip through our fingers, literally.
And just end up everywhere.
Pretty much. dispersing into the environment in ways we haven't even begun to understand.
They brought up silver nanoparticles, right? Those are in all sorts of products these days.
Right, silver nanoparticles, they're great at killing bacteria, so we put them in clothes that never smell, self-cleaning surfaces, all kinds of things.
Sounds convenient.
It does, but those particles don't just disappear. Studies are already showing that they can accumulate in water systems.
And that's bad because...
Well, for starters, it could harm aquatic life.
Hmm.
Fish, plants, the whole ecosystem could be affected.
It's like we're so focused on the immediate benefits, we don't always think about the unintended consequences.
Exactly. And that brings us to another big one, self-replicating nanobots.
Okay, now we're getting into sci-fi territory, right?
Does sound like something straight out of a movie, I'll admit.
Microscopic machines that can build copies of themselves. That's straight out of the Terminator, isn't it?
Well, the alternative world folks did mention the gray goo scenario.
Right, the gray goo,
Yeah.
where these nanobots basically consume everything on Earth, turning it into a giant blob of, well,
Gray goo.
Yeah.
It's a bit of a dramatic example, I'll grant you that.
Okay, but still a little creepy, right?
The underlying concern is real. If we create self-replicating machines, even at the nanoscale, how do we control them? How do we make sure they don't, let's say, get a little too enthusiastic about their replication?
And start using up resources in ways we didn't intend, like turning everything into paper clips or...
Well, hopefully not paper clips. But you see the potential issue, right?
Yeah, okay. So, moving on from the stuff of nightmares, what about something a little more grounded in current events like weapons? Could nanotechnology be used to create a whole new class of terrifyingly effective weapons?
That's not science fiction either, unfortunately. Research into military applications of nanotechnology is already happening.
Okay, that's not reassuring at all.
Think about it. Nano-sized drones, practically invisible to the naked eye, delivering toxins or disabling enemy technology with incredible precision.
So, like, a whole new level of warfare.
Essentially, yes.
And if we're talking invisible threats, what about the stuff we can't see that could be impacting our health? They brought up some concerns about the long-term effects of being exposed to nanoparticles, right?
Absolutely. We've been interacting with nanoparticles in our environment for a long time.
Right, like from pollution and stuff.
Exactly. But with the rise of manufactured nanoparticles, the game is changing.
So, more stuff, potentially more problems.
Potentially. The truth is, we simply don't know the long-term effects of prolonged exposure to these tiny particles.
Like, could they build up in our organs, mess with our DNA? Nobody knows.
Those are the questions we need to be asking. We have some short-term studies.
But when it comes to the long-term effects of nanoparticles on human health,
It's still a big question mark.
comforting. And that's not the only unknown factor, right?
Right. The Alternative World podcast also raised some important questions about the societal impact of nanotechnology, particularly when it comes to equality.
This is where we get into the whole rich get richer scenario, isn't it?
It's a classic concern with any powerful new technology.
Like, imagine a world where only the wealthy can afford the potential benefits of nanotechnology-enhanced abilities, longer lifespans, treatments that make them practically superhuman.
It's a sci-fi trope, but with nanotechnology, it could become reality.
And that creates a whole new set of problems, doesn't it?
It does. If we're not careful, we could see the gap between the haves and the have-nots widen even further, driven by access to this powerful new technology.
It's like they say, with great power.
Comes great responsibility. We can't forget that part. We need to be having these conversations, NW, while nanotechnology is still in its early stages.
Yeah, so we can make sure we're developing it responsibly and ethically.
Precisely.
Okay, I'll admit, we've been painting a pretty bleak picture here.
Well, we do like to keep things realistic here on the Deep Dive.
Uh-huh. Very funny. But in all seriousness, the Alternative World episode wasn't all doom and gloom.
Not at all.
They were actually very clear about the fact that nanotechnology could be the key to solving some of humanity's biggest challenges.
It's like we're standing at a crossroads with the potential to create a brighter future.
It's like we're holding the keys to the kingdom, but we have to figure out which lock they go into. Speaking of solutions, they really emphasize the potential of nanotech to help us combat climate change.
Makes sense, right? I mean, we're talking about manipulating matter at the atomic level.
The same level where those greenhouse gases are doing their thing.
Exactly. And they had some really cool examples, like imagine solar panels so efficient that we could power entire cities with the energy collected from a single rooftop.
Talk about putting all your eggs in one basket.
Okay, maybe not the best analogy, but you get the idea. Incredibly efficient solar energy.
That's just one example, right?
Oh, there's more. They talked about nanomaterials that act like tiny sponges, pulling carbon dioxide right out of the atmosphere, like a giant global air purifier.
That would be incredible. It almost feels like the same precision that makes nanotechnology potentially dangerous could also be our saving grace when it comes to tackling climate change.
It's all about how we use it, right?
Exactly. But we can't just focus on the environment. They also went into some detail about the possibilities in healthcare, right?
Oh, absolutely.
Yeah.
Imagine a world where we could cure diseases like Alzheimer's, Parkinson's, even cancer
Yeah.
by targeting the problem at the cellular level.
Using nanotechnology to deliver treatments with pinpoint accuracy, basically.
Precisely. They even talked about nanobots delivering gene therapy, repairing damaged cells before they can even cause problems.
And personalized medicine tailored to your unique genetic makeup.
No more one-size-fits-all treatments. We'd be talking about healthcare tailored to the individual.
Now that's what I call progress. Okay. But we can't talk about the future of humanity without addressing a pretty major issue: food.
Right. We're going to need a lot more of it to feed a growing population.
And they had some fascinating insights into how nanotechnology could revolutionize agriculture.
Imagine nanosensors embedded in the soil, monitoring conditions and delivering precise amounts of water and nutrients directly to the roots of plants.
It's like giving every plant its own personal gardener.
Exactly. We could potentially increase crop yields dramatically while simultaneously reducing our reliance on pesticides and herbicides.
And they also talked about developing crops that are more resilient to drought, disease, even pests.
Imagine a world without famine, where everyone has access to safe, nutritious food. Nanotechnology could help make that a reality.
It's pretty incredible when you think about it. We've covered a lot of ground here, from the potential perils to the incredible promises of nanotechnology.
And let's not forget about its potential to make us a spacefaring species.
Wait, what? Seriously?
Yeah, lighter, stronger spacecraft, self-repairing materials that can handle the harsh conditions of space.
We could be talking about building structures on Mars with nanomaterials as strong as diamond.
The possibilities are truly mind-boggling. But I think the most important takeaway from the Alternative World episode is that the future of nanotechnology is really a story about humanity's relationship with technology itself.
It's a mirror reflecting back our own potential for both creation and destruction.
And the choices we make today will determine what that reflection looks like tomorrow.
So what do you think? Are we ready to wield the power of the nano world? It's a question worth pondering.
It certainly is.
And we hope this deep dive has given you plenty to think about. Thanks for joining us.